Okay, so now I have a couple questions for you. Before you start answering the questions, think about this. These blue circles are Earth, and these are just examples of locations. So we have northwest, northeast, southeast, southwest. This is position 1. This is position 1. You're going to answer position 1 questions, and then you are going to enter questions about position 2. So go slow. I'm going to repeat the question. If for some reason you can't see it in the presentation, take your time and answer them to the best of your ability. So this one is asking about position 1. Position 1, is it day or night in the northeast? Here's your northeast. Is it day or night? Think about the sun. Think about the axis. Question 2, position 1, is it day or night in the northwest? Question 3, position 1, is it winter or is it summer in the northeast? Question 4, is it winter or summer in the northwest? Question 5, is it day or night in the southeast? Now we're talking about position 2. So here's the southeast. Question 6, is it day or night in the southwest? Question 7, is it winter or summer in the southwest? And finally, is it winter or summer in the southeast of section 2? I hope you guys did good on those. Now, we are going to start and we are going to talk about the formation and motion of galaxies, okay? So, galaxies, nobody was around at the beginning of this. So what we have to do is we have to find evidence in the universe and on our planet about how galaxies and universes and stars and everything were formed. And from all the thousands of scientists that have worked on this since the beginning of man, this is what we've been able to come up with, okay? Everything that we know about that exists ever is contained in the universe. That means all matter, all energy, all space, and all time, okay? The idea and the theory is that a large explosion happened and the universe came into existence. That all matter that existed was inside this little space and it exploded and it created the entire universe that we have now. We also know that the universe is growing at about 2 meters, which about around 6 feet every year. So the universe is still expanding and still growing. Now, we know this through a lot of different things, but one thing that you need to keep in mind is that we learned the most about this through electromagnetic radiation. Electromagnetic radiation has a lot of different things that make up what that is. It's how your microwave works. It's how radios work. It's how your cell phone works. But it gets information. But visible light, things that we can see, right? Things that we can see are a form of this electromagnetic radiation. And we know that the light that we can see travels at the speed of light, which is 300,000 kilometers per second. Okay? So, scientists have used this information to measure and determine the age of the universe. Now, I know it's a big jump. And it's really complicated. And I can honestly tell you that I don't even completely understand how they do it. But you don't need to know how they did it, because I think there's a lot of really, really intense math involved here. But what you do need to know is that using these radio telescopes, bouncing waves off of different things at different distances in the solar system that we have and our universe, off of different stars, we have been able to determine the approximate size of our universe and how far things are from us as a planet, okay? The next thing you need to know about is how stars are formed. Okay? Now, stars are in galaxies, right? And we have a star in our solar system. What happens is that all these different forms of energy, of infrared radiation, heat, and ultraviolet radiation, are all kind of in this gaseous dust bubble. And this is an example of a nebula. This thing of just like gas, matter, and energy. And it's all in here. And the thing that holds it all together is gravity. So when we talk about space, we talk about gravity because everything is formed by gravity, everything's held together by gravity, and if it wasn't for gravity, none of this would exist, and there would be no way for it to move and exist around itself, okay? So gravity is a foundational scientific phenomena for the formation of our universe, our galaxy, and our solar system, okay? It's also what holds us on Earth. So all these things kind of exist in this ball and cloud, right? And what happens is that they just kind of start being attracted to each other and gradually form a star. It takes millions of years. But when a star dies and it explodes, it turns into one of these clouds of dust, which is going to happen to our sun in about 4.5 billion years from now. I don't think any of us will be around to see it happen, though. Okay. So that's how a solar system forms. A galaxy forms in a little bit of a different way. A galaxy consists of a lot of families of stars, gas and space and dust. And galaxies actually exist all over our universe. And they actually typically are attracted to each other and form clusters. You can have a cluster of 10 galaxies that are kind of together over here. And then over here, you can have a galaxy of up to like 10,000 different solar galaxies that are attracted to each other in our universe. So a star is inside a galaxy. Now, this is an image of the Milky Way. And we're off over here in one of these spirals. We're like at the tip of the spiral, and the galaxy is actually rotating. So think about this. The sun is going around itself. It's rotating, right? And all of the planets are revolving around this rotation of the sun. Then the sun is going and traveling in the galaxy. And then the galaxy is moving around too. And then outside the galaxy itself is spinning. It's rotating, and then it's also moving within the universe. So to say that you're standing still is like impossible, except I just want to know how to lose weight using the momentum of the Earth and the sun and the solar system and the galaxy within the universe. Because then I think I'd be really skinny. Okay, so there's different kinds of galaxies. Now, the most common of all these galaxies is a spiral galaxy, which is the one that we live in. We live in a spiral galaxy, right? The Milky Way is a spiral galaxy. And we all kind of move in the same direction, and we're kind of flat. So it's like this disc that's moving, right? We're not like round and globularly. We're actually a flat disc, and we're just kind of moving. It's not flat, but you know what I mean? It's like kind of squishied, and it's like flying like a disc in the air. Then there's an elliptical galaxy. I know this is a horrible image, but elliptical galaxies are just kind of weird. They're shaped kind of like footballs, and they actually revolve around the center. So the whole thing just kind of moves. It's like it's thicker. It's not as flattened out as a spiral galaxy, and it kind of moves, okay? Now, this galaxy center can move in multiple different directions. It can go this way, it can go this way, and it moves in different ways, okay? These galaxies are huge, okay? And that's one thing that you need to learn about elliptical galaxies is that they are really big, and they can actually be millions of light years wide and long, and they can have a lot going on inside them. So even though they're not as common as a spiral galaxy, they are very large. when they do exist. Now, the next one is an irregular galaxy. Now, these are the ones that like we don't even know what to call them. They're like all onto their own. Like, look at this one. This one looks like somebody spit on a window, right? And they can be long and thin. They can be really bad. And what the theory is from scientists is that these galaxies are in locations where other galaxies' sizes and gravitational pull is affecting these other galaxies so that they can't really get a shape going on. Okay? And so they look distorted. And we can't predict how they're going to move because we don't know enough about them because they're all individuals and we don't observe them. So we've talked about a couple different kinds of galaxies now. Now we're going to talk about how our solar system was formed, right? Because let's face it, we're from Earth. We really care about Earth, okay? So what we have decided is that there was a solar system here of something, of some sort in the galaxy, and a supernova occurred. That's what happens when the star actually explodes. And this is the picture of a star just blowing up, okay? A supernova. And then there's all this gas and dust, and all the energy that existed in that sun is just kind of there. And gradually, using gravity, it starts to go into a disk. Everything starts to attract, starts spinning all by itself. The gravitational pull of the larger objects start to go towards the center. And then actually, gradually, over millions of years, it forms a sun. Now, in our solar system, 99.2% of all matter that makes up our solar system is in the sun. The 0.8% left over is what makes up all the planets, all the meteors, all the asteroids, all the matter that makes up our solar system that is not in the sun is only 0.8% of all the matter in our solar system. And gradually, as this holds together, the hotter, denser elements that make up our solar system form this sun. And the gravitational pull of those items keep that together and make the sun. And it just keeps spinning and just keeps spinning. And it's still spinning 4.5 billion years later. Okay? Now, what about our planets? Well, we've got all that leftover matter, right? That 0.8%. And what happened is that we formed 8 planets. Now, the first 4 planets are our rocky planets. And that's Mercury, Venus, Earth, and Mars. That means you can land on these planets. There's dirt. You can take a spaceship there. You can build something there. You can leave something there. You can go back and get it later if the environment doesn't destroy it. But the other 4 planets are actually called the gas giants. And the reason that they're called this is because they are made of different elements that are gaseous. They don't have rocks. You can't land on them. They are literally balls of gases. Now, different gases that have separated into different layers, but all the same gases. Okay? So when you talk about going to visit Jupiter, that would be an impossibility. And we're going to watch a short video on Edpuzzle later in this unit about landing on Jupiter and what it might be like to try and do that. Okay? But in the meantime, know that the 4 rocky planets are the 4 first ones, Mercury, Venus, Earth, and Mars. And the 4 gaseous planets are Jupiter, Saturn, Uranus, and Neptune. Now you want to talk about Pluto. What happened to Pluto? Pluto was considered a planet. But the International Astronomical Society changed what they called and defined a planet. A planet is no longer something a certain size that orbits the sun. Now it has to clear its orbit. That means that anything that might get in the way of Pluto or any of these planets within our solar system, the planet will either take it out, attract it to land on it, or push it out of the way. Pluto has things that come into its orbit that Pluto doesn't do any of those things to. Therefore, Pluto had to take a step down and become just a celestial body that orbits orbits our sun, and no longer be called a planet. Good luck. That's it. You guys have a great day, and I'll see you soon.